Okay guys, so welcome back again to another video. So in this particular video we are going to talk about the generation of carbocations. So there are many ways to generate a carbocation in biosynthetic pathways, right? But we are going to talk about mainly two types, or mainly two pathways. So the first one is using SAM. So we can use the SAM to generate a biosynthesis pathway using SAM. We can use the SAM to generate a carbocation. Okay, so I will use an example for, like, let's say we have an alkene, right? Okay, here we have carbon, double bonded carbon. There can be R groups, hydrogens, anything. So now what happens is, if you remember what the SAM is, right? We have talked about the SAM in our previous videos. If you haven't have a good idea about what the SAM is and how this SAM can operate with molecules, I highly recommend you to go back to that particular video, our first video, to check about the SAM. Okay, I told you you do not need to memorize the exact structure of this SAM molecule, but you need to have the common idea, like there's a sulfur with a positive charge, and there's a methyl group, and there's a adenosine sugar part, and there is this NH2 and carboxylic part. Okay, so now what happens is, there's this double bond, this pi bond act as a nucleophile, right? There's a higher electron density over here. So what happens, this can go and attack to our methyl group. So because of this attack, this bond can be broken and we can obtain carbon. Our methyl group will attach to one particular carbon. This will depend on the steric hindrance and the other R groups and other groups which attach to our particular alkene. So now we have now this pi bond is broken, right? This pi bond has broken to form the new bond with this methyl group for only one particular carbon atom. Now in this case, this carbon atom, you can see it loses an electron, right? It loses an electron, but when the bond forming, it won't get that particular electron to itself, so it will remain as a positive charge. So here we have obtained a carbocation. Okay, this is a very common pathway to obtain a carbocation in biological systems. And the other thing is, this is not common in biological systems, but some complex molecules contain this pathway too. Okay, so let's say we have obtained epoxides. This is an epoxide, and this is an epoxide. So with the epoxide, with the hydration, right, with the addition of H2O, like H plus, like this, so we can convert this epoxide into carbocation, just like this. So these are a particular reactions which we can use to obtain a carbocation. Like, otherwise in biosynthesis pathways, these are the two main pathways. If you see a carbocation forming, then mostly it could be using a SAM or epoxide, but I would say it mostly using a SAM. There are other pathways to obtain a carbocation, but these two are the main thing which I'm going to talk about, or I'm going to focus about. So I hope you got the idea. In next video we're going to talk about another particular rearrangement. So we will meet in the next video.